W5FKN.
This is K5VZ. Does anyone need to use the repeater before we begin tonight?
Welcome to the DCARA repeater W5FKN.
All right, nothing heard. This is K5VZ. My name is Jim, and I'll be the net control station for tonight's net, hosted by the Lewisville Amateur Association. This net is held every Saturday night at 19:30 hours local on this frequency, which is 145.17 megahertz, with a negative offset and a PL tone of 110.9. This net provides education and discussion about amateur radio topics. All stations licensed to transmit on this frequency are welcomed and encouraged to participate by checking in to tonight's net. Tonight's net will be conducted as a directed net in order to practice proper operating procedures. Therefore, please do not transmit without direction from net control, and all stations are reminded to ID themselves at the end of their transmissions. This net will give priority to any emergency or skywarn activation. If there is an emergency or skywarn activation, we'll suspend or end at that time. Stations with emergency or priority traffic may enter the net at any time with the words break, break, followed by your call sign. Is there any emergency or priority traffic for the net? If so, please call net control now. All right, we'll start with check-ins with the alternate net control. Is there an alternate net control out there? Please call control now. All right, nothing heard, so we'll go on without an alternate net control. Any station wishing to check in to tonight's net, please call net control now with your call sign quickly and your first name.
KO0M, Eric.
Whiskey Zulu 5, Go Mike, Tim.
Whiskey 5, Juliet, Kilo, Steve.
Kilo Charlie 5, Mike Pop X-Ray. You can put me down for alternate control if you'd like.
All right, I have Eric, Tim, Steve, and Len. Anybody else wishing to check into tonight's net, please call net control now. All right, nothing heard. So first of all, I want to apologize for having to delay the net by 15 minutes. Had somebody show up, and they were here a little bit longer than said they were going to be. So sorry about that. We'll move forward, and tonight's topic is going to be an introduction to bandpass filter. And the presentation link is out on our Facebook page at facebook.com/WF5LVC. That's Whiskey 5 Lima Victor Charlie. Or you can go to bit.ly. That's Bravo India Tango Lima Yankee /Kilo 5 Zulu -2016-004. As we move forward with the presentation, stop between slides, and if you have a question, you can call your call sign, and we'll take your question in between each slide. So I'll give everybody a couple minutes to get the slide deck up, and then we'll get started. And do me a favor, on the where it says can be found at. Don't click on the page not found thing, or you're going to end up in 404 land. While everybody's doing that, we'll go ahead and we'll do a station ID, and we'll take some more check-ins. This is K5VZ for the Lewisville Amateur Radio Association, subject to be announced net. If there's anybody wanting to check into tonight's net, please call net control now, sign quickly, and your first name. All right, has anybody had any issues getting up the slide deck? If so, call please net control.
W5JK.
Go ahead, Steve.
Yeah, Jim, on the club light there, where was the location again? Could you just repeat that?
Yes, if you go to facebook.com/BF5LVC, it should be the topmost post on Facebook.
Okay, Okay, and if you don't have Facebook?
W5FKN.
If you go to http:// Bravo India Tango Lima Yankee / Kilo 5 Victor Zulu, that's all caps, -20160604. It'd be my call sign, K5VZ, and today's date in year, month, day format. Steve, were you able to get to it?
No, I'm not. Go ahead. Don't wait there. I'll get there and follow along. Go ahead. Go right ahead.
All right, we're going to start out with slide number 3, which is an overview of what we're going to cover tonight, which is what is a filter, the basic principles of filters, the basic types of filters, and we'll do a little light designing of filters and talk about a little bit some design tools. So if we go down to slide number 5, a filter, and the sense of what we're going to talk about tonight is basically a resistive, inductive, and capacitive circuit, or better known as an RLC circuit, that separates some frequencies from others within mixed frequency signals. We use these to block unwanted signals from being transmitted or received, and we can use them to allow desired signals to be transmitted or received. So we can use filters to block stuff out. We could use filters to let stuff through. And slide 6 is an example of a filter. All these are bandpass filters that you might use either to externally from your computer, from your radio, or it actually might be a module that you have built into a radio, as in slide number 7. And what we're trying to do on slide number 8 is filter out harmonics. Anybody can tell me on the net, or anybody on the net tell me what a harmonic is?
WZ5TM.
Go ahead, Tim.
A harmonic is a whole multiplier of a frequency.
That's correct. So if we have a signal at, let's say, 7 megahertz, we might have a second harmonic at 14 megahertz, or a third harmonic at 21 megahertz. And so that could actually cause a lot of noise on the other bands. So what we want to do is we want to filter those harmonics out and only transmit our signal on our desired frequency of 7 megahertz. Now, slide 8 actually shows an example of a main signal and the harmonics, second, third, and fourth harmonics on it. As you can see, they're much lower in signal strength, and what we're going to do is we want to try to knock down any harmonics 3D below, at least 3D below our signal, or more. The more we can knock those signals down, they're going to be, and the less noise and interference we're going to cause on other bands. Does anybody have any questions about generally what a filter is and what harmonics are? All right, starting with slide 9, we're going to start talking about the principles of filters, and we're going to talk about resonance in an RLC circuit. Now, if you've been studying for your general class exam or your extra class exam, you're probably very familiar with resonance in an inductor or a capacitor. With a capacitor, as frequency increases, the impedance or the reactapacitance decreases with frequency. So at DC, a capacitor blocks signals. It'll block DC voltages, it'll block DC current, and as the frequency increases, it'll allow more through. With an inductor at DC, it allows stuff to come through, and as the frequency increases on an inductor, the impedance or the capacitor or the inductive reactance increases. So it will more and more of the current going through the circuit. Now, if you have a capacitor and an inductor in series or in parallel, there is a frequency, which is called the resonant, where the capacitive reactance and the inductive reactance will cancel each one out, and it'll allow the maximum amount of current to go through the circuit. And that's actually what we call resonance, is that frequency. And slide actually covers or shows an example of how the capacitive reactance is very high at low frequencies and then becomes very low at high frequencies, and how it's inverse for an inductor, starting out very low or very high or very low at inductors, going to very high with frequency. Slide number 11 actually gives us, if we know what the value of the inductor capacitor is, we can find that resonant frequency. And normally we take 2 pi times the square root of the inductance in henries and the capacitance in farads, and then divide that into 1, and that'll give us our resonant frequency.
W5FKN.
And we'll take a break here and do station identification and take some more check-ins, and then we'll continue on with the presentation. This is 5VZ for the Lewisville Amateur Radio Association's subject to be announced net. If you'd like to check into tonight's net, please call Net Control now. All right, nothing heard. So before we move on, does anybody have any questions about resonant frequency, or how we determine that, or how a capacitor and an inductor will react together? If so, please call Net Control now. All right, then, nothing heard, so let's continue with slide 12. Now, if we have a known capacitance or known inductance, we know what frequency we want to allow through, we can actually calculate the corresponding component values. So if we have a capacitor, let's say we've got a 36 picofarad capacitor, and we want to know what in size inductor we need in order to allow, let's say, 7.050 megahertz through, we can actually take and calculate that. So what we're going to do is we're going to take the square of 2 pi times the resonant frequency and multiply that by our capacitance and divide that into 1, and that's going to give us the value of our inductor in henries. And we could do the same thing, we just substitute the capacitance and the inductance out if we have an inductor that we're looking for a capacitor that we can use at that frequency. So slide 13 actually shows something that's rather important and a lot of people don't usually catch, but with a series LC circuit at impedance, your minimum impedance will be at resonant frequency. So that means that when the circuit is resonant, it'll let the most current through the circuit. And so if we have a capacitor and an inductor in parallel, and we're at the resonant frequency, we'll be at our maximum impedance, which means that basically we'll get the least amount of current through the circuit. So on slide 14, what does this all mean? Basically, we want to use series RLC circuits to pass frequencies. And we want to use parallel RC circuits to block frequency. Basically, the input energy at the resonant frequency is passed through the filter to the output in a series circuit. And any input energy that's not at the resonant frequency is going to be reflected back to the input as an impedance match or mismatch. What's going to happen is anything below that resonant frequency of, let's say, 7.050 megahertz, it's going to basically be degraded and reflected back to the input, and anything on the opposite side of that is going to be reflected back. So we're going to get a narrow band frequencies that we're going to allow through. So if we use those things, we could come up with different types of bandpassers based off of a series and a parallel RLC circuits. And on slide number 16, we have a low passer. And so what we do is we actually build the circuit in such a way that it passes frequencies below a specified cutoff frequency. So anything below that will pass through, and anything above that frequency will be degraded. And again, what we're looking at is our cutoff frequency is going to be where the signal drops below 3 dB of our input. On slide 17, we have a high-pass filter. And so what we're going to do with a high-pass filter is we're going to degrade the signal for any frequencies below our cutoff frequency. And anything above our cutoff frequency is going to be allowed through. And then in slide 18, we have a bandpass filter. And what we're going to do is we're going to use a little more complex circuit, and we're going to basically have cutoff frequency, a low cutoff frequency, and a high cutoff frequency. And anything that's between those two frequencies will be allowed through, and anything outside of those two frequencies will actually be degraded and will be reflected back. On slide 10, we have what's called a band stop filter, and what it's going to do is it's going to use a low and high cutoff frequency to block the signals between the low and the high. And so you get what is normally called a notch filter. Does anybody have any questions about the types of filters? All right, well, when they're talking about filters, you're going to come across some common filter designs that people will use. And again, these are with LC circuits. You have the Butterworth filter, which is designed to be maximally flat within the pass band. And then it's basically going to have a slow taper off. It's used when smoothly varying the phase response is important to minimize signal distortion. And then you have the Chebyshev, which allows ripples of amplitude to occur within the pass band, but there's a very steep cutoff. And it's normally used when we need a sharp filter to increase attenuation in the stop band. And we don't care so much about the signal phase in the pass band. And slide 21, you have some examples of the output curves for filters. In the upper left-hand corner, you have an example of a Butterworth, and then there's in the upper right is an example of a Chebyshev Type 1 and Type 2, and then we also have an elliptic, which is another type. It's very similar to the Chebyshev, but it has a very, very steep drop-off. All right, do we have any questions about basic R filters? Because that's pretty much going to wind up our presentation for tonight. I didn't want to get too deep into it. We could go into some more stuff around designing that, but I figured we'd take it with small bites. So if anybody has any questions, please call Net Control now.
WZ5TM.
Go ahead, Tim.
Okay, I have a question. If some of these filters are built into your radio, how do you know which ones to use and when?
All right, well, I'll tell you what. Steve, hopefully you're on, and I know Lynn is. If you guys might want to speak up from experience, otherwise I'll take a stab at it.
Okay, well, I'll take a shot at it there, just at a very high level, W5JK. I guess one of the uses that you would see in a modern day receiver, even in some of the older receivers that had non-DSP radios, they had, you'll see a lot of filters called Collins filters. It was a brand of filters, and they would be sometimes on the front ends of the radios, and you might see some common denominations of these filters. It might be 15 kilohertz, or you might have a 6 kilohertz filter, and they may step down, Tim, in various steps, and maybe from 6 they go down to say 2.4, and then maybe down to 1,000 hertz, and then as you get down into CW and data modes, you might even get down as low as 600, 300, 250 hertz. And what these are used for, some of the radios today are they're called roofing filters, and what they do is they restrict when you have a lot of QRM on either side of you. You can start running your bandpass filter down. Some of them are called DSP filters today. It kind of does the same thing except in software. But when you start reducing the bandwidth on these filters, it will start to the skirts of that envelope there of the signal there, it starts to cut down the QRM on the sides of it. It kind of puts up a wall-like because you're decreasing the bandwidth, and the narrower you go, the more it will cut out, and eventually you could get it so low, depending if you're listening to single sideband or if you're listening to a data mode or a CW, you can skinny it down so small that the signal may be unrecognizable, voice might be unrecognizable. So you have to fatten it back up a little bit, make it a little bit wider to maintain the intelligibility of the signal, but at the same time cut down that QRM on the side. So that's kind of how they're used today, and a lot of that is just by ear. How much of that QRM is bothering you, and you can start to narrow it down with your filters till it becomes more copyable or less objectionable. Back to you, Jim. W5JK.
Len, you have anything to add to that? Or Eric?
KC5MPX. I tell you, I use my filters depending on what is, what's coming in, what signals I'm getting. Sometimes you can filter out the junk and get what you want. I mean, Steve had some good points there. It's all about, basically just, sometimes you need them, sometimes you don't. Sometimes you can hear more without them. Sometimes you can clear your signals up coming in and actually get the guy that you can notch some of your notch filters, notch out things and that. So anyway, that's all I have to add.
Thank you both for that information. W5TM, back to net.
Eric, I heard you start or come in there. Go ahead.
Both Lynn and him said, perfect things. And what I've got several different ones. I've got contour, I've got notch, I've got DNR, I've got width, and I've got knobs I can shift the signal back and forth in case somebody's machine isn't exactly on frequency. And what I do with a lot of those is I get it down, like he said, you keep clipping it down, and then I start back and forth until I can hear what I like and what my ears will pick up. And since I have a hearing problem, what I set my filters at may be totally different than what you set your filters at, what Lynn sets his filters at, and what Jim sets his filters at. It's kind of one of those, it's a preference, I would say. Back to net.
All right, thanks, Eric and Steve and Len. The other thing, Tim, is we can actually, if we have a lot of radios close by to each other operating on different bands, we can also use low-pass and high-pass filters and band-pass filters to kind of cut some of the interference to those radios that are close by to us as well. So we could set a filter that will basically filter out everything but the 40-meter band, and that way anybody that's transmitting on that particular radio on 40 meters isn't going to affect the else that's next to them. And they could have one that's a 20-meter bandpass filter, and that's going to basically block down those signals outside of 20 meters. That's another use for these. And we're sitting around and we've got a lot of transmitters together operating on different bands. That comes in real handy.
W5FKN.
Another good filter is like a notch filter that you can use, especially when there's a lot of activity on the band and you're chasing a rare DX, like somebody that might be doing an island, or they might have a rarely sought after thing, and you can use a notch filter to notch out those people that are constantly calling while you're talking to that station and getting that contact, and that it will help clean up that signal so you can understand it a little bit better. Hopefully that helps you. Anybody else have any other questions around filters or around RLC circuits? All right, nothing heard. So let's go. We'll do station identification one more time, and then we'll move on into some general announcements. So this is K5VZ for the Lewisville Amateur Radio Association topic to be a net on the W5FKN repeater. If there's any other stations that would like to check into tonight's net, please call Net Control now. All right, nothing heard. So we're going to open it up for general announcements. So anybody that has a general announcement of an amateur radio nature, club-related or activity-related, or they've got something that they'd like to buy, sell, swap, or trade, call Net Control now.
W5JK.
Go ahead, Steve.
Okay, thank you, Jim. I've got a couple items that I'm going to be putting up on the for sale block that are excess to my needs right now, and probably down the road there for sure. I'll start out. I have a Yaesu FT 736R, Foxtrot Tango 736R. It is a UHF, VHF, all-mode transceiver, and it's got 4 modules slots in there, plug-in modules in the back of the radio. And it's equipped right now with 3 of those 4 slots are filled with a module for 144 megahertz, module for 430 megahertz, and a module for 50 megahertz, which is 6 meters. And there's one slot in there. It's a vacant slot, and it could be used for another band like 1.2 gig or something like that if you're into the satellite stuff. And I've got a couple various accessories that work with that radio as well. I've got a communication speaker. It's got two channels, 2 inputs on an A or a B. And this particular speaker, it's a Yaesu SP767 speaker. It's got 6 built-in filters for it, and these are audio filters. And I also have a Yaesu MD1 dynamic microphone that works well with the radio. And okay, that's on the VHF UHF side. I also have an amplifier that's excess to my needs. I have a Heathkit SB1000. That's a 1,000 watt amplifier. It uses a 3500 Z tube in there, and it's 10 through 80 meters, or 10 through 160. And then I have an SDR radio, software-defined radio. It's a 10-tech Orion 565. And let me reset here. W5JK. It's a 10-tech Orion 565. It's got a built-in and a tuner, and it's at the latest software version release. It's got two receivers in there. It's got a ham band and a general coverage, 10 through 160 meters, plus a general coverage, and it has a full set of roofing filters on both sides of the radio, both receivers. It comes with 15 kilohertz, 6 kilohertz, 2.4. Those are standard filters that come with the radio, and then it has optional filters, 1 kilohertz, 600, and 300. And Tim, if you're still listening yet, those, when you start getting down to the 1 kilohertz, the 600, and the 300, you're down into the RIDI and the data and the CW. Are the typical applications for those narrower filters, and 2.4, even kilohertz, maybe there's a little bit on single sideband, and then your AM, you use your higher filters like the 15 kilohertz and 6 kilohertz there. It's a great DXing radio, contest radio. It was just back 10-tech in late 2013, had a full checkup, full scan, and a couple of capacitors replaced, and a full alignment. Okay, back to you, Jim. If anybody's interested in any of that equipment, you can send me an email at skline4 verizon.net, skline4@verizon.net, or you can call me on my cell phone, 972-679-6288. And welcome to come over and look at the equipment, operate it. We can hook it up, run it, and see if you like it or not. Back to you, Jim. W5JK.
All right, thanks a lot, Steve. I don't know what it is. Everybody's like clearing out their equipment lately. But no, it sounds like you got some good equipment up there that you're looking to pass on to somebody. So if anybody's interested, please get in touch with Steve. Anybody else got any announcements or anything for buy, sell, swap, or trade?
W5FKN.
AC5MPX.
Go ahead, Mr. Lynn.
Well, I think that there should be a want segment in there too. But anyway, for buy, sell, swap, or trade, anyone need any coax? I have coax. I have plenty of coax. I'll make you a great deal on it. Just let me know what you need. We probably have some. I acquired a box of coax today that we can probably set someone up real nice if they need a good run of it's different RG8, 58, some hardline, different things. So just depending on what you need, you can contact me, on the air, email me, mycallsign@gmail, or you can always call me, and my number is 972-965-9082. Back to net, KC5MPX.
Oh, you're looking to get rid of your found treasure today. Wow. Okay. Thank you, Len. Anybody else got any announcements or anything for buy, sell, swap, or trade?
$1 million, does that count? KO0M.
Sorry, I think we all want that. Okay, well, I've got a couple of announcements. One, next weekend will be HamCom, so, save your niece in that and head down to the Irving Convention Center. It'll be both Friday and Saturday, and I think they open up at 7 a.m. both days, and they'll be going till about 7 p.m. It's the biggest amateur convention in Texas, so it's well worth going to. And then the following weekend, we will have our meeting, and then at the end of the month, we've got Field Day, and there's sign-up links on the website. We're looking for people that can donate equipment, want to operate radios, want to help set up and tear down. So please go out there and volunteer. And if anybody else has anything else, I'll take one last call for any other announcements.
KC5 MPX.
Go ahead, Len.
I just want to throw it out there that we have a new app on the cell phone where, you know, we can give you it's almost like a walkie-talkie feature. We can also send instant messages. Like I sent some to others that are already on it. It's the WhatsApp. So if we have your phone number, if you send me your phone number and I have it in my phone and you have the WhatsApp, like tonight's net, we send it out there. If we have some club activity going on, it's another way of notifying people. We also do Facebook. We also send out the weekly updates. So if you're not getting those things, you should let us know. If you're not getting the weekly updates, you know, always let us know so we can get those things out to members so you know what's going on with the club. This is KC5 MPX, back to net.
All right, thank you. All right, with that, I'd like to go ahead and conclude this session of the Lewisville Amateur Radio Association's topic to be announced net. All stations are invited to call us on the air following the net with any questions. So I'd like to thank you all for participation tonight and hope to hear from you again next week. In the meantime, enjoy the rest of your weekend and the upcoming week, and y'all have a pleasant night. This is A5BZ returning the W5FKN repeater back to normal use and closing the net at 20:30 hours local.